Welcome to GSD Smart Water channel. We will regularly bring you the latest smart water products and application cases of GSD. Today, I would like to introduce to you the Digital Twin System for Sewage Treatment AAO process set up in the Water Resources Center of an Agricultural Science and Technology Park in Taiwan. The system is independently developed by GSD. It is a smart water optimization and monitoring system based on digital twins and artificial intelligence technology. Relying on this system, this traditional sewage plant has been successfully upgraded to a water resource reuse and management center. The AAO treatment process in the biochemical section is intercepted here. Click the three buttons Anaerobic Tank, Anoxic Tank, and Aerobic Tank on the top of the interface to quickly switch the management interface of the corresponding area. Now the left area of the interface presents the three microbial activity index data of pH, ORP, and MLSS in the anaerobic tank. Each index is expressed in the form of a continuous line graph. The blue line represents the actual value measured from the sensor, and the yellow line represents the data of the index after rinsing. The two lines are related but not completely consistent. Its purpose is to let the operator or manager understand the variation trend of biological index in the tank, to assist operators in making decisions, and intervene in advance to deal with abnormal situations. The middle and lower areas of the interface present the hardware equipment associated with the anaerobic tank. Here, the relevant data of the sludge return pump is intercepted, including its operating status, power, frequency, return flow rate, and other noted data. The area on the right side of the interface presents the water quality indicators in the anaerobic tank, including chemical oxygen demand, COD, ammonia nitrogen, nitrate nitrogen, phosphate, and other indicators, all indicators been organized into a line chart. The comparison of power consumption mainly shows the energy consumption which compared horizontally under different control modes. The overall interface layout of the anoxic tank, also the aerobic tank, is almost exactly the same as the anaerobic tank. The main difference is that the equipment associated with the anoxic tank is the nitrifying liquid internal return pump, and the equipment associated with the aerobic tank is the aeration blower. The reference value of DO is added in the microbial activity index. The overall style is unified, the interface is clear, and the idea of modular design is adopted. It can achieve on-demand rectification, in customization and serial data adjustment, to meet the actual needs of operation and management. The interface with a fixed perspective is important, but the digital twin aims to reproduce the real physical scene and give real-time feedback. Therefore, after rapid 3D modeling and lightweighting, we realized a series of details such as environmental scenes, hardware equipment, pipeline instruments, and hydrological conditions. At the same time, we also simulated day and night changes and environmental changes under different weather conditions. It can be described as the superposition of fiction and reality, with details everywhere. Let us follow the flow of sewage and travel through the entire AAO process. After being treated in the pre-treatment process, the sewage water is sent to the biochemical section. The first unit to enter is the distribution channel. At this moment, the biochemical reaction was started. The second unit is the anaerobic tank. You can see that a mixer is working. The three water quality data in the anaerobic tank can be real-time monitored. The third unit is the anoxic tank. Under the reaction of denitrifying bacteria, the nitrate nitrogen is turned into nitrogen and released into the air, and the three water quality data in the anoxic tank can be real-time monitored. The fourth unit is the aerobic tank. You can see that the bubbles are gushing out from the aeration diffusers. Most of the chemical oxygen demand, nitrate nitrogen, and phosphate have been treated in this tank. Carbon is oxidized to carbon dioxide, ammonia nitrogen is oxidized to nitrate nitrogen, and phosphate is absorbed into the sludge by microorganisms. The four water quality data in the aerobic tank can be real-time monitoring. The overflow were at the end with the functions of regulating the water effluent also separating the suspended solids at the same time. It is also possible to implement a free perspective of the whole scene. In this state, we can visit the entire treatment process or the whole sewage plant in an all-round way without dead ends. Click the AI Intelligent Prediction button in the upper left corner, and you will be able to understand the two aspects of the AI model, what it is doing, and what is expected to happen. To give a few examples, if the predicted value of ORP in the AI mode is less than the value after filtration/rinsing, it means that the suggestion value after the comprehensive calculation of the AI model need to fine-tune upwards, and the deeper meaning behind it is the phosphorus removal bacteria concentration of existing sludge is not enough to cope with the next influent peak of wastewater. So the ORP should adjust increasingly to release phosphorus in advance, the actual implementation. Control step is to upward the frequency of sludge return pump so that to increase the return flow quantities of sludge to supplement the proportion of phosphorus removal bacteria. In the meantime, if the aeration blower under high power consuming, the due prediction value is higher than the value after cleaning and rinsing, it means that the dissolved oxygen in the existing aeration tank is surplus. It is a compromise decision made by the oxygen content of the aeration tank and can counter-control the total amount of aeration of the blower in time to save energy. GSD's Smart Water AIoT system has been applied to many wastewater treatment plant projects, effectively providing strong support for wastewater operation, management and decisions making, and it is truly empowering users' actual operation and maintenance. GSD can provide one-stop customization services, from project consulting, products application, system development, IoT and AI intelligent or smart platform setting, providing full-range supporting services to meet the various customers' needs in an all-round way.